This is section 10.4, lines and planes in space. These are the objectives. Find equations of planes in space, find angles formed between two planes. The last one is find distances between points and planes in space. Let me read this to you. The standard equation of a plane in space. The standard equation of a plane in space containing the point, what you see here, and having normal vector, what you see here, is the following equation that you have here. So let me just summarize what this is saying. Whenever you want to find the equation of a plane, all you need is a point on the plane and a normal vector to the plane, and plug it into this equation and you're done. Normal vector to a plane, again, copy this, and let me just summarize what this is saying. Whenever you have a plane, you can find the normal vector to a plane by just looking at the coefficients that are in front of the x, y, and the z, and that's basically the vector that you that is in component form, that is normal to the plane. Planes with normal vectors n1 and n2. So you're going to be finding some information about planes, but you're not going to be working with the actual planes. You're going to be working with the normal vectors to the planes. So the first one is, if you want to find the angle between two planes, you work with the normal vectors to the planes, and then this is the formula that you use. The dot product of the two normal vectors over the magnitude of each of those normal vectors, and you use cosine of theta, and then find theta. Parallel planes, so you're looking at the normal vectors, and if this happens, there's a scalar that makes them both equal, they're parallel. Perpendicular planes work with the normal vectors, and if the dot product is equal to 0, they're perpendicular. And the distance between a plane and a point Q is given by this formula, where point P is on the plane and N1 is normal to the plane. So the distance is basically, take the point that is on the plane, the point Q that is not on the plane, find the component form of that vector, multiply it times the, take the dot product of that PQ and the normal vector, find the absolute value, and then divide it by the magnitude of n sub the normal vector, and then that's basically your distance. This will make a little bit more sense when we actually apply it to one of the examples. So let's move on to the next slide. It says find the general form of the equation of the plane passing through the point and normal to the specified vector or line. So equation of the plane, you have a point that is on the plane, a normal vector, a perpendicular vector to the plane. So all you're going to do is you're going to use this formula that you saw earlier. We're going to substitute information here. 3, 1, 1. That's your A, B, C. Your x of 1, y of 1, z of 1 are here. Once you have this, distribute the 3, the 1, and the 1. Simplify this by combining the negative 3 and the 3, and this is your answer. Let's move on to number 2. So here's number 2. Find the general form of the equation of the plane passing through the 3 points that you see there. So the first thing that we're going to do, we are going to find, so again, this is the formula that we're going to be using. All I need is a point and a normal vector to the plane. So first, I'm going to find component form of these two vectors, VA, VC. Notice the same initial point. Once I have these two vectors, I find the cross product of them, and again I get a new vector, and as you may know, this vector is orthogonal to these two vectors, and these two vectors are in the plane that these 3 points are. So now that I have the normal vector, I'm going to pick a point. I choose to work with point A, normal vector, plug it into this formula. I get the following. I clean it up, and this is my answer. This is the standard form of the plane passing through these 3 points. Let's move on to number 3. So this is determine whether the planes are parallel, orthogonal, or neither. If they are neither parallel nor orthogonal, find the angle of intersection. So first, these are the formulas that I'm going to be looking at. So they're parallel if we have this, perpendicular if they have this, and if there are none of these, I can find the angle by using this formula. So these are the normal vectors. This is the normal vector to the first plane, normal vector to the second plane, and I notice that this is not possible, so they are not parallel. Secondly, take the dot product and it's equal to 6, so they are not perpendicular. So now I'm going to find the angle of intersection of the two planes. So I use cosine of theta. The dot product of these two is 6. The magnitude of both of them, 6 and 17. Radical 6 and radical 17. Use my inverse function for cosine, and I get 53.55 degrees. Let's move on to the next slide. And this is the last problem. It says find the distance between the point and the plane. So we have this plane. This point is not on the plane. So this is the formula that we're going to be using. So I need a point that is on a plane. This is the point that is on this plane. How do I get this point? I basically find the x-intercept by letting y equal to 0 and z equal to 0 and solve for x. I could have also found the y-intercept or even the z-intercept. But anyway, let's move on. So now I find PQ, and this is the this is the vector that I get in component form. So then this is my normal vector to the plane, 1, negative 1, and 2. And then I plug it into the formula, take the dot product, I get negative 1, find the magnitude of the normal vector, and simplify. And this is the distance between the plane and the point. And this basically concludes the video.